Hi guys, well done on doing the exam. So this is just the introduction to our chemistry marking scheme. I hope the exam went okay for you. I hope it just gives you a few pointers for the leaving cert and maybe highlight some areas you need to do a bit of revision in. And yeah, hope it went well for you. I'm just going to go through a few details about the marking scheme. I want to thank Adele Healy for her help in putting the exam together and all the editing and formatting and all that stuff. And thanks to Deborah and Conrad for all the work behind the scenes. And hopefully there's no errors in this as we go through it. And my email is on the screen there. If you have any questions about any of the questions in the marking scheme, or you have some alternative method of doing a question you want to run it by me, please do send in an email to me at that email address. So just a few bits and pieces about the marking scheme, and this is all in the Leaving Cert marking schemes too, in the introduction. So the bold text generally indicates the essential points required in your answer. If there's a double slash that separates points for which separate marks are allocated. If there's a single slash, that just gives alternatives for an answer. Okay. Generally, the names and formulas of elements and compounds are equally acceptable. There's a deduction of 1 mark for arithmetical slips. If you're calculating a relative molecular mass, that 1 mark is deducted only if you show your addition. Okay, if you don't show the addition for the relative molecular mass and you get it wrong, then you lose the mark for that part. Okay, so hopefully that's clear. And look, I'll bring all that up again as I'm going through it question by question. So that's it. Moving on now to working my way through the marking scheme for you. Okay. Okay, Conrad, that's the end of the introduction. Now I'll be moving on to question 1. 5, 4. Okay, guys, question 1. This is our titration question. 50 marks, as are all the questions in Leaving Cert Chemistry. So let's start working our way through this. So a group of students carried out a titration by titrating some washing soda crystals, represented by Na2CO3XH2O, against a 0.075 molar solution of a previously standardized solution of hydrochloric acid. They had no method of weighing the washing soda crystals, so approximated, dissolved in deionized water and made up accurately to 500 centimeter cubed in a volumetric flask. It said on the washing soda package that the percentage water of crystallization was 59%. So explain the underlying term, which is previously standardized. So previously standardized means that the concentration was found by another titration, and you have your options in there, the molarity found by colorimetry or UV spectroscopy. Okay, 4 marks for saying that the concentration of the molarity was known. All right. Part B, using a pH meter, the students determined that the pH of the washing soda was 11. Explain why a standard solution of ethanoic acid would not have been suitable for this experiment. So this would have made this a weak acid versus weak base titration. Okay, sodium carbonate is a weak base, ethanoic acid is a weak acid, and there's no clear end point and no indicator is suitable for this type of titration. Describe the correct procedure for preparing and using a burette in the titration. So for this, you need 3 marks, 3 good points, 3 by 3. Okay, so 9 marks in total. So your options are rinse with deionized water, rinse with a little of the solution that's contained, which is HCl, clamp vertically, use a funnel, remove the funnel, make sure you fill the jet, the part below the tap, make sure the base meniscus is on the 0 mark. So any 3 of those, but you must have 3 of them to get the 9 marks there. Name a suitable indicator for this titration. State the color change in the titration flask at the endpoint. So the indicator we use for this titration is methyl orange. Color change to the endpoint is orange to red, or yellow to pink, or you have your options in there. Okay, as long as you have both of those colors in there, you get the full marks. Then onto our calculation. In the experiment, it was found that 25 centimeter cube portions of the washing soda required titration figures of 20.8 centimeter cubed, 19.9 and 20 centimeter cubed of the 0.075 molar hydrochloric acid solution. The titration reaction is as follows. Calculate the number of moles of hydrochloric acid used in the reaction. So we're told that we have a 0.075 molar solution of HCl, which is 0.075 moles per liter. Okay. However, we only used 19.95 centimeter cubed of HCl. Where do we get 19.95 from? Well, we can see there that our three titration figures are 20.8, 19.9, and 20. Okay, so we ignore the first one because that is a rough titration. Then we get the average of the second and third one, which gives us 19.95. And that's always the case if you're given three titration figures in a question. So we know what the moles per liter are, which is 1,000 centimeters cubed. So we've 0.075 divided by 1,000 multiplied by 19.95, which gives us 1.496 by 10 to the minus 3 moles in our 19.95 centimeter cubed. So you have your 6 marks there for working that out. So to get you don't have to include the units, just 1.496 by 10 to the minus 3 gets you the marks. And if you didn't have 0.075 moles per liter written out specifically, that doesn't matter as long as you got it from 1,000 down to 19.95. That's the main thing there. Okay. Calculate the number of grams of sodium carbonate required to react with this quantity of hydrochloric acid. So we can use one method is to use your V1M1 over N1 formula. So we have 19.95 of the hydrochloric acid. The molarity of it is 0.075. We divide it by 2 because that's the number of moles of HCl indicated on the left-hand side of your equation, was equal to 25 of our sodium carbonate by the unknown molarity over 1. Okay, you do your calculations there. The molarity of your sodium carbonate is 0.0299 moles per liter. Now it asks for the number of grams required to react with this quantity of HCl. So we didn't use a liter of sodium carbonate. We used 25 centimeter cube. But first of all, I got it into grams per liter. So I multiplied by 106, which is the relative molecular mass of sodium carbonate. And then I got my grams per 25 centimeter cube. So again, I had 3.169 divided by 1,000 multiplied by 25 is 0.079 grams per 25 centimeter cubed. You could get it from moles per liter to moles per 25 and then into grams. You can do in that order as well. As long as you get your 0.079, you get your marks there. Now, an alternative method of doing that, okay, is as follows. I'm just going to work through that very quickly. Is you take the number of moles from the last part, 1.496 by 10 to the minus 3. You divide it by 2 because you have a 2:1 ratio of sodium carbonate to HCl, okay, and you get 7.48 by 10 to the minus 4, okay. So because it's HCl to Na2CO3 is 2:1, so you must divide by 2 to get the Na2CO3. Then you multiply that by 106 and you get 0.079 grams. Okay, so either method is fine there, using your mole ratio or using the V1M1 over N1. Okay, again, any questions about that, drop me an email. Okay. Calculate how many grams of washing soda the students dissolved and made up to 500 centimeter cube solution. So our volumetric flask was 500 centimeters cubed. So the grams of sodium carbonate in 25 centimeter cubed was 79. To get it up to 500, we multiply by 20, so 1.58 grams per 500 centimeter cubed. Now, on the package, it said that the water crystallization was 59%. That means the percentage of sodium carbonate was 41%. This is because washing soda is made up of both water and sodium carbonate. Okay, so 59% is water. That means 41% is Na2CO3. So 1.58 grams is 41%. We get 100% by dividing by 41 and multiply by 100. And we get 3.85 grams of Na2CO3 XH2O. So that's how much they weighed out initially using our water crystallization percentage. And then finally, we're asked to calculate the value of X, which is the average number of water molecules in that formula, Na2CO3 X H2O. So again, going back to our percentages, we know that 41% of the total molecule is Na2CO3 because we were told that 59% is water. So that means the relative molecular mass of Na2CO3 is 41% of the overall relative molecular mass. So 106 grams is equal to 41% of the total relative molecular mass of the full molecule. So again, you get 100%. So 106 divided by 41 and multiplied by 100, you get 258.5 grams. Okay, so Na2CO3 XH2O is equal to 258.5. So then we split up our molecule into two parts. Then the Na2CO3 is 106 grams. Water, which is H2O, is 18 grams, and we have X molecules of it. So we have 106 plus 18X gives us 258.5 grams. So 18X is equal to 258.5 minus 106. 18X is 152.5. So X is equal to 8.47, and anything from 8 to 9 is acceptable there to get you your 3 marks. And again, I'm fully aware that there's other methods for working this out. And if you have one and you're not sure about it, send me on a picture of it and I can give you advice on how many marks you would get for it. Okay, so that ends question 1 of our exam.